So in this video, we're going to talk about naming ionic compounds. All right. And so what are the conventions of naming an ionic compound? If you get something like NaCl, how do we name this? Or if we get MgO, how do we name this? Or if we get MnF4, how do we name this? All right. And so depending on what it's made up of, or what type of metal it is, and what type of non-metal it is, then it goes to very specific naming conventions. All right, and so we're going to kind of talk about that in this video. So there's two different types of ionic compounds. All right, two types of naming conventions when it comes to ionic compounds, and we just simply in chemistry we just simply call it type 1 and type 2. All right, so when we look at type 1 are ionic compounds that contains cations of main group elements. So what are these cations that we're talking about that's from main group elements? Well, we're talking about the alkali metals. All right, so the alkali metals consist of all the metals in the first column, so like sodium, lithium, these guys, right? Potassium. And then we have also includes the alkaline earth metals. So the alkaline earth metals are the metals in the second column. So beryllium, magnesium, that calcium, that column. Okay. And then we're also including aluminum and indium as well. This is also considered to be a main group element. So what's so special about these guys? Well, these metals only have one charge, one specific charge. Okay. And so metals with one charge. And we'll talk about how that comes into play when it comes to naming these ionic compounds. So let's talk about type 2 ionic compounds. So type 2 ionic compounds consist of metals that exhibit more than one charge. In other words, the charges of these metals, all right, they vary. All right, the charge of the metals, wow, the handwriting is pretty bad. The charge of the metals, all right, the charge of metals, they varies. All right, and so we kind of talk about this in previous videos. Like for example, copper could be a +1 or copper could be a +2. So it varies between what's the possible charges between one metal to the next. So these metals are typically your transition metals. So the metals that you find in the center area of the periodic table, your heavy metals. All right, so these are the metals that you typically find under the non-metals, under that staircase towards the right. All right, so these guys typically, when they're bonded to a non-metal, they follow type 2 naming rules. Okay, so let's go ahead and dive into each of these naming rules. So let's first talk about type 1. So for type 1 compounds, two things that you just have to remember. All right, so the charges of the cation, it doesn't vary. It stays the same. That's also true with the anions, but that's always true with the anions, regardless if it's type 1 or type 2. And then secondly, you do not specify the charge of the cation within the chemical formula itself. All right, and so for example, if you're looking at NaCl, right, and we will just name the ion, right, as is. So your metal always comes first, so you'll write sodium, all right, and then we will name the ion of the anion. In this case will be chloride. So remember, just make sure you review the videos of how to name ions or atoms when they become ions. Okay, so that's an example. Here's another one. Let's say we have MgCO3. All right, well, this will be magnesium. All right, remember magnesium ion, but we just don't ever use the word ion. Magnesium, and this is a polyatomic. So you just got to make sure you know your polyatomic, CO3, and this is carbonate. So MgCO3 is magnesium carbonate. So you never include, or if you have a compound, ionic compound, in this case for type 1, and it has a subscript, the subscript never appears in the name itself. So like for example, if you have something like Li3PO4, PO4. Okay, all you have to do just name the compound as you see it. So Li3, Li is just simply your lithium ion, so we'll just write lithium. And then PO4 is your polyatomic. You figure out what's the name of this polyatomic, and we'll see that it is phosphate. So the compound here is just simply lithium phosphate. All right. For type 2, remember, ionic compounds contain metals that can exhibit more than one charge. So these metals, the charges varies, right? So what you will do is that in the name itself, you will have to specify the charge of the cation using Roman numerals, okay? And so, for example, let's say we have CuCl2. All right. So what you need to do is first figure out what is the charge of Cu. What's the charge of copper? All right. Now, the best way you can kind of figure this out is just use the anion to kind of guide you. Okay. What we do know is that the charge of this overall compound is 0. Remember, all ionic compounds, the charge is 0. Okay. And so if that's the case, well, we know chlorine or chloride, okay, always have a charge of -1 based on the periodic table. Well, how many chlorides do you have? Well, I have 2 of them. So there's 2 -1s here. All right. And so in a way that you could kind of think about this, mathematically speaking, is what -2 is equal to 0? Well, it needs to be +2, right? And then we have to split up this charge of +2 to all the different, all the cations. All right. And so here, since we only have one cation, one copper, all right, this one copper has a charge of +2. All right. And so when we write the name, it'll be copper, Roman numeral 2 to represent the charge, chloride. Okay. Let's look at another example. So let's say that we have MnO. Okay. So we need to figure out what is the charge of Mn, manganese, right? I mean, we know it's going to be manganese something oxide, but we got to figure out what's that Roman numeral. Okay, so the way we're going to figure it out is that we're going to figure out what's the charge of the anion. Okay, we know that oxygen has a charge of -2. We know that. And then together as a compound, the compound has a charge of 0. So what -2 equals 0? Well, you guessed it. It has to be +2. And so simply because there's only one manganese, so this one manganese has a charge of +2. So it's manganese 2 oxide. Let me rewrite this so it looks better. Manganese 2 oxide. Okay. Let's do a couple of more. I like this. Let's do more. All right. So let's say that we have FeClO3. All right. So what is this, right? All right, so remember, we got to use our anion to figure out what's the charge of our metal, okay, of our cation. All right, we know that this is hypochlorite, all right, and the charge of hypochlorite is a -1. All right, how many -1s we have? How many hypochlorites do we have? We have 3 of them. So 1, 2, 3. So if we have 3 of those, and we're looking at this one iron here, so what must be the charge of iron in order to neutralize this -3 charge? Okay, and the charge of iron to neutralize the -3 charge must be a +3. So when you write this is iron 3 hypochlorite. Okay, let's do another example of this. So let's say we have this compound here, Cu2O. All right. And so, as I said before, and when writing this, you need to figure what's the charge of your metal. We need to figure what's the charge of copper. We know it's going to be copper something oxide, but what's that Roman numeral, right? And so we know that the chemical formula, its overall charge is 0. And then we see here that oxygen, its chemical or its charge, the charge for oxygen is a -2. All right. So what minus 2 equals 0? Well, right. It has to be plus 2. Now, when you look at this, there are 2 coppers. All right. And so altogether, the charge of these 2 coppers together has a overall positive charge of plus 2. So what's the charge of each copper? Well, each copper must have a charge of plus 1. Okay. And so that will be the Roman numeral. In this case, it'll be copper 1 oxide. So let's do one more example, and let's actually use a polyatomic this time with a transition metal. So let's say that we have we have this compound here. All right, we're trying to name it. So remember, as I said before, you want to make sure that that you figure out what is the charge of your cation, right? Because that charge is going to become the Roman numeral. So we know it's going to be manganese ion, right? Something. This is your polyatomic phosphate. All right, so let's figure out what's this Roman numeral here. As I said before, we know that the overall charge of this compound has to be 0. And then we got to use the anion to help us out. So what's the anion here in this case? Well, the anion is phosphate. What's the charge of phosphate? It's a -3. How many phosphates do we have? Well, we got 5 of them. So it's these 5. And so if we add them all up, we have a -15. Well, if that's the case, all right, then when we're looking at manganese, right, what minus 15 equals 0? Well, what minus 15 equals 0 is a plus 15. All right. And so if you notice, there are 3 of them. Okay. So these manganese all together has a plus 15 charge. And so if you kind of do the division there, then we'll see that each manganese must have a plus 5 charge. If each manganese has a plus 5 charge, this plus 5 is what we place here as a Roman numeral, and so it's manganese 5 phosphate. All right, and so that's how we go about naming these type 2 compounds.